In this video, we are going to discuss about dolomite. Yes, dolomite is very common mineral, especially before Precambrian. It was primarily possible to be precipitated, but in present day art, most of the times it occur white dolomitization, a secondary process in which calcite gradually transformed into dolomite because of isomorphic substitution of magnesium in calcium lattice, ionic position of calcite, because since there is a limited substitution, because calcium and magnesium are not having similar ionic radii, there is 30% larger. Calcium are more than 30% larger than magnesium cation. So it is going to be an interesting topic. Please stay tuned. First of all, what is dolomite? See, dolomite is CaMgCO3 whole 2. But keep it in mind that Mg percentage is fixed. Most of the times it is observed that 40 to 55% magnesium content is found in dolomite. Okay, more than 55% or 60% magnesium in CaCO3 will be regarded as magnesite. There is a solid solution series between two N members. In the left end, that is calcite CaCO3, pure CaCO3, and in the right side, pure magnesite MgCO3. But in nature, entire solid solution is not possible. There is a miscibility gap. Like we have seen oil and water, for example. They cannot mix. Not necessarily both are liquid means they will be mixing. It is found similarly in nature also. There are certain composition which is possible to be mixed. Other than that composition, there are certain compositional range in which these two solid cannot be mixed, and we cannot get any kind of Mg and Ca percentage minerals. There is a series, but in which certain proportion is not possible to be developed, like magnesite 25% to magnesite 40%. These kinds of magnesite content in calcite is not possible in nature. Yes, so that portion it is highlighted here. See, all composition is possible. Magnesite 0 to magnesite 25. Okay, magnesite 0 means calcite 100. Magnesite 4 means calcite 96. Just their total will be 100. Calcite plus magnesite will be 100. Okay, so magnesite 0 means calcite 100. Magnesite 4 means calcite 96%. Magnesite 25 means calcite 75%. Now, beyond that, there is observed that magnesite 25 to magnesite 40, this range is not possible to be developed. After that, again magnesite 40, calcite 60, and so on is possible. But in this particular range, magnesite 25%, that means calcite 70, magnesite 75, magnesite 25, calcite 60, magnesite 40. This composition is not found in nature. This is not possible to be developed because there is a miscibility gap. This miscibility gap means it is observed that they cannot occur. They cannot be formed, this kind of phase. Okay. So theoretically, dolomite contains, theoretically if we see standardized, if we do, it contains 54.35% CaCO3 and 45.65% MgCO3. Obviously, it can be fluctuated, so that's what I have told. 40 to 55% MgCO3 is must to be defined a dolomite. Now, high Mg dolomite, low Mg dolomite. High Mg means it will have to be around 55, not beyond that. And low Mg dolomite means it have to be around 40, not below that. So it is very restricted composition. MgCO3 must be there within 40 to 55% range, remaining is calcite. So that particular composition is called dolomite. Okay, so in this composition, if we see now component wise, CaO will be 30%, 30.4 around, MgO will be 21.7%, and rest are CO2. So therefore a limited solid solution can exist between the n member components, as calcium cations are more than 30% larger than magnesium. Although these two cations are having similar charge, same charge rather, +2, but because of ionic radii differences, it is more than 30%, so limited substitution occurs. Because the amount of substitution is limited, now what will happen? Many potential compositions do not exist in nature. That is, here I am showing this blue colored portion. This is potential compositional variation, but it is not possible to be developed. Okay, such gap in solid solution series are called miscibility gap, by analogy with immiscible liquids that do not mix in certain proportion. I hope you understood. Now, in this series, a miscibility gap exists between 25 to 40, magnesite 25 to 40, calcite 75 to 60. So this proportion composition is not possible. Again and again I have been repeating, because this is very important to understand dolomitization process as well. So these kinds of beyond that it is possible. Now in present day earth, primary dolomite is not at all possible to be formed. Of course, during Precambrian, before Precambrian, there are so many primary dolomitization examples are existing. And dolomitization means calcite gradually converted into dolomite because of limited substitution process of magnesium into the calcium. So calcium get replaced partially. Okay, but of course within a limit. But during Precambrian, their condition was such that dolomite primarily could be developed, because to form primary dolomite, first of all, how do we recognize that it was primary? Because dolomitization process give different phenomena, like partially digested calcite. So calcite, partially dolomitized part, that kind of undigested calcite is possible to be recognized in ordinary petrography microscope as well, in which we can see some portion is getting dolomitized. Undigested calcite is also observed to be located. But in Proterozoic earth, most of the dolomitic formations, entire dolomite, no calcite or undigested calcite was found. And moreover, if you see the chemical composition MgO versus CaO, we will be getting positive correlation. In case of Precambrian, MgO and CaO is getting increased together or decreased together. So these kinds of positive correlation indicate no dolomitization or replacement. Replacement in present earth is showing negative correlation, because magnesium is coming in place of calcium. So gradually calcium will decrease, magnesium will increase. So these kinds of negative correlation indicate dolomitization process. Whereas in case of primary dolomite, CaO and MgO both give positive correlation coefficient. Okay, now so many organisms secrete cells in the range of calcite. Calcite means it is also categorized into two types. Of course, in calcite also some magnesium will be there, but it is not possible to be define those as dolomite, because dolomite is prescribed, it fixed. MgO content must be from 40 to 55%. In case of calcite, MgO ranges from 0 to up to 25%, not beyond that. So from magnesite, in terms you can understand in terms of MgO as well. So in case of calcite, magnesite content is restricted up to 25%. So if 0 to 4% MgCO3 is present, that is called low Mg calcite, and 4 to 25% magnesite content in calcite is called high Mg calcite. So in between these two high Mg and low Mg calcite, it is observed that most of the organisms secrete cells in low Mg calcite region in general. And within this range, we can define low magnesium calcite and high magnesium calcite in terms of their proportion of calcite and magnesite in members. Now, what about that dolomite then? If we see from 40 to 55%, beyond this, it will be regarded as magnesite. Okay. So, low Mg calcite generally contains less than 4% magnesium, substituting for calcium in the structural site. So it is having a composition range of 96 to 100 calcite and magnesite 0 to 4. Okay. Vice versa, in case of high Mg calcite, 25%, as I have discussed already. So dolomite is always showing 40 to 55% magnesite. That's all for this. I hope you understand the importance. Thank you.